Hello friends, welcome to our YouTube channel and lecture series of solid state. In the previous 7 lectures, we have seen different concepts regarding the number of atoms per unit cell, packing of unit cell, packing efficiency and the density of a unit cell in case of simple cubic, body centered and also FCC crystalline lattice. Today we will see the number of problems based on these concepts, and it is very necessary to know that in board examination different questions are asked, numerical problems are asked on this topic. This topic is for 6 marks, and out of 6 marks every time the question is asked on the numerical problems for 3 marks. That means only 3 marks is for theory questions and a problem of 3 marks is asked. Hence today I will give some hints to how to solve the problems, and also we will see some board question papers questions on this topic. And the previously asked HSC board questions, if we see the first question, I have already mentioned this, distinguish between crystalline solid and amorphous solid, and this question was asked for 2013, 14, 17 and also 2019. That means 4 times this question is asked for 2 marks, and you have to write 4 distinguishing characters between crystalline and amorphous solids. I have already discussed. And the second question, calculate the percentage efficiency of packing in case of simple cubic cell. This question was asked in March 2017 for 2 marks again. And in the previous lecture we have seen the packing efficiency in case of simple cubic cell, body centered and FCC. For 2 marks you can write that, calculate the number of atoms in a unit cell of metal crystallizing in FCC structure. Number of atoms, how we calculated, that means in case of FCC the number of atoms are present at the corners, 8 corners, and the contribution is 1/8. Hence 8 into 1/8, 1 molecule or 1 particle, and each face has a atom and its contribution is 1/2. 6 into 1/2, 3 plus 1, 4. We have already seen that, and this question was asked in July 2017. And niobium, now the numerical based question, niobium crystallizes as a body centered cube and has a density of 8.55 kg per dm cube. Calculate the atomic radius of niobium. Atomic mass of niobium is equal to 93, and this question was asked March 2015. And hence I have given some hints how to remember and how to calculate these things. And we must know the formula of density is equal to n into capital M divided by a cube into Na. डेन्सिटीचा हा फॉर्म्युला आहे की ज्याच्यामध्ये n म्हणजे नंबर ऑफ पार्टिकल्स पर युनिट सेल, की जे आपण वेगवेगळ्या सिस्टीमसाठी पाहिले. क्यूबिक सिस्टीमसाठी 1 पार्टिकल असते, तर बॉडी सेंटरसाठी 2 पार्टिकल्स, n इज इक्वल टू 2, आणि FCC साठी आपण पाहिले की 4 पार्टिकल्स असतात. इथं आपण हे दिलेलं आहे म्हणून तो 1, 2 आणि 4 ही यांची किंमत आहे. ॲटॉमिक मास दिलेला असतात की जसं 93 हे ॲटॉमिक मास निओबियमचा आहे. ए क्यूब म्हणजे ए आपल्याला दिलेलं असतं, याच्यामध्ये दिलेला आहे ए. आय थिंक ए इज नॉट गिवन, वी हॅव टू कॅल्क्युलेट इट. एम इज गिवन, एन इफ BCC we have to take 2, and Na it is the Avogadro number, and density is given, it is 8.55 kg per dm cube, and we have to take it into the grams per centimeter cube, and hence we can calculate by using this formula. You try to calculate the density by using this formula, and remember very carefully, the question is always asked on this relation. And also if we have to calculate the radius Here atomic radius of niobium is asked, and for body centered cubic lattice R is equal to 0.433 A. By using first you calculate the A by using this equation, and by using R is equal to 0.433 A you can calculate the radius, and this question is asked for 3 marks. We will solve the question like this. The silver crystallizes in FCC structure if density of silver is 10.51 gram per centimeter cube. Calculate the volume of unit cell. Here volume of unit cell, that means A cube, is asked. Atomic mass of AgM is given, and it is a FCC structure, hence face centered structure. 4 atoms are there. N is equal to 4, M is equal to 108. We have to calculate A cube, and the density is given 10.51 grams per centimeter cube, and Na is the Avogadro number. You have to remember the value of Avogadro number, which we have seen in 11th standard. It is 6.022 into 10 raised to 23, and hence you can solve this also problem. Try to solve these all problems. The density of iron crystal is 8.54 gram per centimeter cube if length of unit cell is 2.8 angstrom. Here I missed to write angstrom, and atomic mass is 56 gram per mole. Find the number of atoms in the unit cell, and this question was asked March 2018. That means every year the question on the relationship between density, molar mass or atomic mass, and the number of atoms per unit cell, volume of unit cell are asked, and the value of Na, it is constant 6.022 into 10 raised to 23 atoms, molecules. 1 mole of any substance contains these molecules. And also in 2014, face centered cubic lattice of copper has the density is given. Calculate the volume of unit cell. You have to calculate again volume A cube, that means volume of unit cell, and density rho is given. Again it is FCC, hence N is equal to 4, M is given 63.5. we know the value of Na, and hence we can calculate. Hence very carefully remember this formula. You will able to solve all these problems, and these questions which were repeatedly asked you have to know. Hence I have mentioned here previously asked HSC board question. Another definitions are also asked in the 2019 March 2019. The definition of anisotropy was asked. Again classification of solids as a covalent solid, molecular solid, ionic solid. It is also asked, or classify the following molecules. I have already mentioned these questions, and along with these questions, these are the some few questions I have mentioned here, and we will today solve some of the problems based on this density. One problem in the previous session already we have solved, but we have to see 2 relations and the problems like this. The unit cell of metallic silver is FCC. Here FCC structure is given. If radius of Ag atom, silver atom, is 144.4 picometer, and here the radius is given in picometer, we have to convert it into centimeter. Calculate edge length of unit cell, and we know the relationship between edge length and radius in case of FCC. In the previous chart we have seen the relationship between, here the relationship between R and A. For FCC, R is equal to 0.3535 A, and hence we will use the relation. Then volume of Ag atom 4/3 pi r cube, we can calculate it. The percentage of the volume of unit cell that is occupied by Ag atoms, that also we can calculate, because there are 4 atoms per unit cell in case of silver, and so we will multiply by 4 to the volume of one particle, and then the percent of empty space. For that we must calculate the percentage of packing, that is packing efficiency we must calculate. Then we can calculate the empty space. By using the previously mentioned formulae, we can first calculate for FCC unit cell R is equal to 0.3535A. This value you must know, and by using, I already mentioned that we have to convert picometer into centimeter. For that, first picometer means 10 raised to minus 12 meter. You remember this from physics also, and in the chemistry units, picometer is converted into meter. That means whatever the value, it is multiplied by 10 raised to minus 12 meter, it will convert picometer to meter, then convert into centimeter by multiplying 100, and if we multiply this by 100, you will get 144.4 into 10 raised to minus 10 centimeter. And again this value can be used here. A is equal to R upon 0.3535, 144.4 into 10 raised to minus 10 centimeter divided by 0.3535, you will get 4.085 into 10 raised to minus 8 centimeter. You can use log table for this calculation. In the previous problem, I have given how to see the log and anti-logs, and how to add logs and subtract also. You have to use log table for the calculation, because calculator is not allowed in the examination. By using A, we can now calculate volume of Ag atom. For that, we will again require R, and we know these are the spheres. Atoms are considered as a sphere, and volume of sphere is equal to 4 by 3 pi R cube. Hence the value of pi is 3.142 into 144.4 into 10 raised to minus 10 centimeter cube. Here we have already calculated the radius in centimeter from picometer, and you have to put the value of R, and the volume of Ag atom will be 1.261 into 10 raised to minus 23 centimeter cube. But in case of FCC structure, there are 4 atoms, hence we will calculate the total volume of the spheres, that is occupied volume by spheres. Volume occupied by 4 Ag atoms is equal to 4 into 1.26 into 10 raised to minus 23 centimeter cube, and here you will get 5.044 into 10 raised to minus 23 centimeter cube. This calculation you must do by using log table. And here total volume of unit cell, we know A cube. The volume of unit cell is always A cube, whether it is a simple cubic, body centered or FCC. The total volume of unit cell is calculated as A cube, and hence A cube is equal to 6.817 into 10 raised to minus 23 centimeter cube. Here first you calculate the cube of 4.085, and then 8 into 3, 24, it will be 24, and if you take the cube of this 68, and hence the point is towards the left side by one digit, 6.817 into 10 raised to minus 23 centimeter cube. It is the total value, and we know the packing efficiency. Now we have to calculate the empty space. Before that, you must calculate the packing efficiency, and for that, packing efficiency is equal to, we know the formula. Remember, try to remember the formula. And we have here two things. The दोन गोष्टी आपल्याकडे आहेत. टोटल व्हॉल्यूम आपल्याला मिळालेला आहे युनिट सेलचं, आणि आपल्याला दुसरं एक मिळालेलं आहे की किती व्हॉल्यूम पार्टिकलने ऑक्युपाय केलेला आहे. हे जे आहे ते व्हॉल्यूम पार्टिकलने ऑक्युपाय केलेलं आहे, आणि हे टोटल व्हॉल्यूम आहे. तर आपल्या पॅकिंग इफिशियन्सी or percentage of volume occupied by Ag atom or packing efficiency is calculated by using volume occupied by atoms in unit cell. This is the volume occupied by atoms in the unit cell, as there are 4 atoms and the volume occupied by 4 atoms is this value, and total volume of unit cell it is 6.817 into 10 raised to minus 23 centimeter cube into 100. If we calculate this, we must get 74%, and in FCC we know we have calculated the empty space is 26% and the space occupied by the particle in FCC is 74%. And by using this problem, we can also prove the in case of FCC 70% of the space of the unit cell is occupied by the particles while 26% is empty space. Hence this type of question or problem can be asked for 3 to 4 marks, and you have to put only the values. First you have to mention the given things and you can use the formulae and to solve the problem. Now another relation we will see here, a very important relation, number of particles and unit cell. Number of unit cells, number of particles can be calculated from the mass of the metallic crystals. That means if 5 gram of metallic crystal is given, a particular metallic crystal is given, we can calculate the number of particles in it, and also you can calculate unit cells. For that we will use the first relation, rho is equal to, again that relation, n into m a cube into na, where rho is the density, n is the number of particles per unit cell, m is the molar mass or atomic mass, a cube is the volume of unit cell, Na is the Avogadro number. We will rearrange the equation. M is equal to rho into a cube into Na upon n. Only I have rearranged this equation, and we know number of particles in x gram of metal. For that we must know the relationship between 1 mole of any substance contains Na particle, that means 6.022 into 10 raised to 23 particles, and is known as Avogadro's law. 1 mole of any substance, remember Avogadro's law, 1 mole of any substance contains Avogadro number, that is 6.022 into 10 raised to 23 particles, atoms, ions or molecules. Hence x gram of metal contains x into Na divided by m. Multiplication, cross multiplication, you have to do x into Na divided by m, and you will get the number of particles which are present in x gram. We will put the value of m, it is the value of m, you will put the value of m here. Substitution of m gives number of particles in x gram. Number of particles in x gram is equal to x into Na. X into Na, instead of m we will use rho into a cube into Na divided by n, and Na get cancelled. This n will be here, and hence it will become, the formula will become number of particles in x gram is equal to x into n divided by rho into a cube. And in this way, by using this formula, it is a very important formula again, and we have derived this formula by using rho is equal to n into m a cube into Na. Hence this formula rho is equal to nm a cube into Na. It is very important formula. By using this we have derived the new formula by which we can calculate the number of particles directly from the mass of the metallic crystal. For that we must know whether it is a BCC, FCC or simple unit cubic cell, also its a density and its a volume. If we know these things, we can calculate the number of particles in the, and also the unit cell. For the calculation of number of unit cell in x gram, another formula will take this relation, n particle correspond to 1 unit cell. That means if 2 particles are present, it is a BCC. If 4 particles are present, it is the FCC. That means 1 unit cell correspond to n particle. For BCC, 1 unit cell will have 2 particles, FCC will have 4 particles, simple cubic will have 1 particle. That means n particle correspond to 1 unit cell. Then this much particle, this much amount of particles correspond to how much? N get cancelled, and we get x upon rho into a cube. Only here n is not, because we have rearranged the equation. Hence, by using these two formulae, we can calculate number of particles and number of unit cell in the given gram of metallic crystal. 0.5 gram of metallic crystal is given, 0.4 gram of metallic crystal can be given. We can calculate directly the number of particles and also number of unit cell in that much gram of metallic crystal, and we will see the problem based on this. Niobium forms BCC structure. The density of niobium is 8.5 gram per centimeter cube, and length of unit cell is 330.6 picometer. How many atoms and unit cells are present in 0.5 gram of niobium? Here again remember the formulae. We have to calculate the number of atoms and unit cell, and now we can write the number of atoms in x gram of niobium is equal to x into n, where x is the mass of niobium which is given 0.5 gram, n is the number of particles and is a BCC, hence number of particles is equal to 2. Rho is the density, it is given 8.55 gram per centimeter cube, and here A is given. We can calculate the value of A. It is equal to 330.6 picometer, and you have to convert it into centimeter. Always remember, picometer is converted into centimeter. How it can be converted? Picometer is nothing but 10 raised to minus 12 meter. Then multiply by 100, you will get centimeter, and hence it is a 3.306 into 10 raised to minus 8 centimeter. By rearranging, you will get the value 3.306 into 10 raised to minus 8 centimeter. By this, you can calculate by putting the values in this formula. Number of atoms is equal to x, here 0.5 gram, n is equal to 2 for BCC, rho is 8.55 gram per centimeter cube, and a cube is equal to 3.306 into 10 raised to minus 8 centimeter cube, and you will get 3.25 into 10 raised to 21 by using log table. Then number of unit cells in x gram. Here the formula is used x into n. You will cancel the n here, only n can be removed, and you will get number of unit cell in x gram, x upon rho into a cube, and hence is equal to 0.5 into 2. It is not required here. 8.55 gram per centimeter cube into 3.306 into 10 raised to minus 8 centimeter cube is equal to 1.62 into 10 raised to 22. Here is the mistake in the textbook, and I have taken as it is from the textbook. Hence 0.5 gram divided by rho into a cube. Here 2 is by mistake, and hence we will get 1.62 into 10 raised to 21